the wording on this problem is a little confusing. So the test is 99.7% effective, so it means the test will accurately come back negative if the antibody is not present 99.7% of the time. So we're focusing on people who do not have the antibody. So the probability of testing negative is 0.997. Probability of testing positive when you do not have the antibody is 0.003. And again, I know that wording is a little bit confusing. So the first part's asking, what is the probability that the test comes back negative for all 6 people? So the probability of negative, and we want all 6 people. So the first person, the second, the third, the fourth, the fifth, the sixth. This is the multiplication rule for independent events. So the first person's chances of coming back negative when they do not have the antibody is 0.997. And each person is independent. So we're going to multiply that by the second person, 0.997, all the way across for all 6 people. So it's 0.997 raised to the 6th power for all 6 people. Or you can multiply 0.997 by itself 6 times. For part B, this is the tricky one, the probability of at least one positive. So the rule I teach in the videos is that's 1 minus the probability of not at least one positive. So that is 1 minus the probability not at least one positive means that they're all negative. So this is where I say none. None of what you want. If you want at least one positive, none of what you want is all negative, which is what we figured out in the first part. So it's 1 minus that same calculation, 0.997 to the 6th power. So all negative would be the same thing we talked about in part A. So for part A, it's all negative, so 0.997 to the 6th power. For part B, at least one positive is 1 minus not at least one positive. That's the complement rule. That's your none rule. So it's 1 minus all being negative, which is the calculation for part A. So hopefully that clears it up a little bit. I know the wording on this one was a little tricky.